Earth's average global temperature has increased about 2 degrees Fahrenheit, about 1.2 degrees Celsius. This heating is already causing harm throughout the planet. How can a temperature increase of just a few degrees cause so much damage? Well, our planet is a very complicated system. To answer this question, we can use a very helpful, powerful tool called systems thinking. First of all, what is a system? A system is a group of parts that interact to form a whole that is different than the separated parts. Let's start with a simple system: salt. The salt you put on food is made of sodium and chlorine. Sodium is a silvery metal that causes a fire if it is put in water. Chlorine is a poisonous green gas. When sodium and chlorine combine, the resulting system is a crystalline white solid that is safe to eat and that harmlessly dissolves in water. This kind of thing happens all the time. Systems generally have very different properties than their parts. Since the whole system does not have the same features as the parts, the new properties of the system seem to have come out of some mysterious place. Scientists say that the system has emergent properties. A great example is the taste of salt. Where did that come from? Actually, the taste of salt emerges within a larger system that includes both salt and an animal, such as a deer. When the deer licks salt, cells in its tongue send signals to the deer's brain, which then result in the deer experiencing a salty taste. This also makes the deer feel good, so it eats more salt. Salt by itself does not have a taste. The animal by itself does not experience the taste of salt. The taste of salt is a property that only emerges when salt touches an organism's tongue, and that tongue then sends signals through nerves to the organism's brain. Now, let's consider the system of a human being. A human being has many body parts. Most of these parts are part of body subsystems, such as the immune system, nervous system, respiratory system, and digestive system. A person has emergent properties, such as a competitive personality, and emotions such as happiness, and physical features such as a body temperature. None of these emergent properties exist in any single part of the body. Where does a person's body temperature, for example, come from? You can measure it in different parts of the body, but those individual body parts do not by themselves create the body temperature. Instead, a person's body temperature emerges from the interactions of many parts of the person's body with each other and with the outside environment. A person's normal body temperature is generally between 97 and 99 degrees Fahrenheit. A subconscious subsystem within the human body tries to keep the internal body temperature stable. If a person gets too cold, that subsystem causes the body to shiver, which warms the body. If a person gets too hot, that subsystem causes sweating, which cools the body. Very dangerous consequences can happen if the body temperature becomes just 4 to 6 degrees Fahrenheit hotter or colder than normal. Similar to a person's body, Earth has many parts. These are often described as 4 Earth subsystems: the atmosphere, biosphere, hydrosphere, and geosphere. These subsystems constantly interact with each other. They also interact with the inflow of solar energy. Earth's global temperature is an emergent property. None of the Earth's subsystems by itself creates Earth's global temperature. Earth's global temperature primarily results from the inflow of the sun's radiation. Each of the Earth's subsystems participates in reflecting and or absorbing that solar energy, moving the absorbed solar energy within the entire Earth system, and eventually radiating that absorbed energy to outer space. The net result is Earth's global climate. Earth's web of life and human societies have adapted to the pre-industrial global climate. Increasing the global climate temperature by just 4 to 6 degrees Fahrenheit would have huge, very long-term negative consequences for both human societies and for Earth's web of life. Systems thinking and modeling help us understand the causes and consequences of our climate crisis. Fortunately, systems thinking can also help us choose the best strategies to significantly reduce the amount of climate change and the damage that it causes. If we work joyously together as state, national, and global systems that help our planet heal, we might get to celebrate the emergence of a just and sustainable future for the biosphere, including us.
Hi everyone! If you enjoyed this video, please leave a like and subscribe to this channel for more climate science videos. Special thanks to UC Berkeley's Understanding Global Change project for letting us use their amazing Earth Systems illustration. You can check out their website and Dr. Art's blog on systems thinking by visiting the links in the description box below. Thanks for watching!